This presentation includes a live demonstration. So, without further delay, let's please welcome Scott.
Hi. Thanks for coming out. This is probably going to be pretty cutting-edge stuff for government, but I'll talk a little bit about myself first so you know my background. I'm actually part of the Docker Captains program, and I'm the only one in APAC. So that basically means that Docker actually authorizes what I say, and I'm allowed to talk on their behalf officially, which is really awesome because I get to play with their new stuff. I have also worked in highly secure environments, so probably not as secure as some of the people in-house at the moment, but I've done ISM unclassified. And I have done consulting for ISM unclassified for Docker across multiple government agencies. And I know a few of them are going to ASD at the moment and getting this through, so they're going to take the IRAP assessment for this because it's not on the list of authorized applications, obviously. But yeah, so this is happening in government agencies at the moment. This talk is based around that you already have infrastructure as a code set up. And it's also going to be quite challenging because I'm going to question, is the tool chain that enterprise security uses valid anymore in the life of containers, which some people will find quite provocative, but I'll do a demo and show you why. So as I spoke about, does the traditional InfoSec toolchain work efficiently in a world where containers' average lifespan is 2 days? So if you're running every night your Nessus and you want to SSH into a box, would you install SSH into your container so Nessus could get in there? What you're actually doing then is increasing the attack vector because you should only have one process running in the container. Now you've got OpenSSH running in the container. That comes with its own box of worms. But you want to scan it to make sure that there's no vulnerable images, right? So how does this fit together? It comes at a loggerhead now where enterprise security actually has not matured yet to catch up with containers. I know Tenable just acquired a company that's starting to do this, but it's still really early yet for them. I know Microsoft spent a bucket of money on Aqua Security, I think somewhere to the tune of $9 million, and they've got their own product, and then there's Twistlock out there that has got a product as well. Today what I'm going to actually show you is 100% open source. So the open source community has seen that there's been an issue with security and containers, and they've gone ahead and built stuff, and it works really well. If you bolt all this in for an auditing point of view to your build server, say it be Jenkins, you've got an audit trail of everything that's happening. If you restrict access to your actual boxes and only have Jenkins make either API calls or SSH calls, you've got an audit trail of who's logged in. So these products by themselves don't necessarily have an audit trail, but you can make an audit trail. You can bolt all these together, and if you've got a good logging stack as well, the audit trail will be within your logging stack. So what we're going to talk about, container security and how it's different to traditional security. We're going to look at how to protect our container. I'm not going to go into high-end schedulers and how to do cross-data center replication with Kubernetes securely. That's a talk to itself. We're just going to look at a single application running in a single container and how to protect that, because I think that's the fundamentals that most people aren't getting at the moment. So if we talk about that, I can come back at another time and talk to you about how to get Kubernetes cross data centers on OpenStack securely. But as I said, that is a beast of a talk, and it would be its talk in its own right. And then we're going to look at how InfoSec and CD works together, because at the moment, most traditional InfoSec, all the InfoSec people that I've worked with, don't get CD, don't get rapid change, don't get how they can be a part of it, which is culturally, it's not a technical issue. They just don't get how CD, they have skin in the game, or why they should be involved in CD, because it's so obscure to them that they should be involved in the deployment process, because usual InfoSec looks at what's running in production. But you can actually, as I'll go to the next talk, the traditional way of InfoSec is actually reactive. So that's like Nessus scanning when something's there. It's actually looking after the production state of something while it's there. And then if you get hacked, it's like, hey, we've got the alerting, we know we've just been hacked. What containers allow you to do is totally flip that on its head. It actually allows you to ship secure containers and be proactive. So you can know what's running in the container. You can lock it down so you've got no attack vector except for the process running in the container. You can put security controls around the container when it's running, so if it does get compromised, you can kill it. And there's a whole heap of stuff you can do now to be proactive instead of reactive, which I think is like really powerful when you start to ship apps. So here's some examples I spoke about. So you've got your traditional security apps, like you've got HIDS, you've got Nessus, you've got AV. In the container world, do you need to run antivirus in a container if you're only running one process? And if you apply a security profile, so nothing else in that container can run except that process, is it beneficial to run AV? Because now you're introducing more processes into the actual container, and you're actually allowing more things to run inside the container. So it's a trade-off. Do you want to know exactly what's running there and lock off like kernel modules and file systems so there's only a single process running there and nothing else can run? Or do you want to put AV in there to report back to you, but then you're going to have to give it access to a whole lot of file systems that the single process or application you're running doesn't need? So that's a trade-off, and that's where most of my conversations with like the InfoSec guides around ISM unclass gets to. And the new way of doing it is use something like appapparmor. Appapparmor will allow you to run a profile that can be source controlled, it can be signed off by InfoSec, and it will say only this process can run in the container. You've got a full audit trail of the policy that's been applied to the container. And as I said, you can pull a pull. This is one of the things I set up, is you can put a pull request into InfoSec and get them to sign off on it. Now, when I introduced that process, they were like, what's a pull request? And I was like, I just need your sign off and your approval that this is the right process with appapparmor that you think is secure to run a single container, a single process in a container. And once you get them saying, yeah, it looks good to me, and the pull request gets approved, then you can start pushing that out into a production environment. So now you're starting to get security in at the beginning and not the end of a deployment process. Once the culture and the mindset starts to change, they'll start to really see the value in this, because they'll start to look at how they can start to protect their assets before they get to production. And with containers, because you're shipping the signed off image, they know at that point in time when that image was built, they have the security controls that they needed, and the process has been upheld. And I'll go into how we can keep updating it so it's CD and it's dynamic and you get sign off for it. But at the time when that container's built, if you've got the right appapparmor process, you've got the right signing tools, security should be 100% impress and sign off that is exactly what they signed off on. There's no changes. They've seen the code, they've seen the appapparmor process, and we've signed it with the crypto that they've given us. So I'll get into that a bit further on. So that's appapparmor. Claire is a vulnerability scanner built by CoreOS that allows you actually to scan the image before the container is built. So if you build this into your CD process, and you, say, pull an upstream Nginx container and it's built on Debian Jessie. The Docker container for Debian Jessie has the glibc vulnerability unpatched in it right now on Docker Hub. If you ship that, you wouldn't have known if you didn't have a vulnerability scan on it. It is, you can go to Docker Hub now, click the tags in the library items, and then look if they're vulnerable. But if we step back 5 years ago, if you're in a highly secure environment, would you download a VMware image from Microsoft and trust that it would work? That's what you're doing with Docker Hub and containers, right? It's no different. You're trusting that the vendor out there is upheld the security and you're going to fork it. Well, you'll be surprised how many vulnerabilities are in the library containers. If you're in a highly secure environment, probably what you want to do is fork them yourself, put the Docker file in your own repository. You might have to make changes to run patching at the beginning, at the build process. And then what you need to do as part of the build process, you need Claire to scan the image to make sure that there is no vulnerabilities there. If there is vulnerabilities within the image, it doesn't get shipped. You send a message to the developer or the team that's responsible for that and go, hey, there's vulnerability, CVE, and it will give you the CVE numbers that it's vulnerable to. You can pipe that information out and back to the developers and say, hey, we can't ship this. This is got a CVE in it. Now, some CVEs you might need to ship, but that's fine. You can go back to the InfoSec team and go, like, for example, we were using RabbitMQ. There was a CVE in it that Rabbit hadn't patched yet. I was able to go to the InfoSec manager and he was able to put a business risk case around it and say why we needed to use that. But that was his decision, and he also had all the information that he needed to be able to make an informed decision whether he would take on the risk or not. So that's what Claire allows you to do. And putting vulnerability scanning before you launch something is a lot better, I believe, than doing it after it's launched. Oh, been talking too long, sorry. And last one that's there is a Docker application called Notary. So what Notary does is once this build process has gone through, so you're happy with it's got the right appapparmor profile, you're happy that it's got no vulnerabilities in it, you want to sign it to make sure that there's no tampering with it now. So all you need is whatever cryptocurrency or crypto that security wants you to use, and that's just a signing key. And you can revoke it and pull it back depending on how your PKI is set up. But I leveraged that from security. I didn't make up my own crypto for this. I just said, hey, I need this. This is what the signing process is going to be. And they gave it to me. So they were still in control of the crypto. I didn't have any control over that. But the good thing about it is we had, at that point of time, a signed image with a crypto that wasn't in our team. And we had the audit process to say that it was signed off at this point of time. So some of the risks that we're trying to protect in containers is DDoS to the host. So the CPU, DDoS, memory, or disk. The fork bomb. That is really easy to do if there's a kernel vulnerability. Docker will only ever be as secure as the kernel you're running. If you're running a kernel that you know has got vulnerabilities in it, Docker's got that vulnerability. So you're only using Linux namespaces. So if you can get into the namespace and you know you can do proof escalation or you know you can fork bomb the local host, you'll be able to do it and you'll be able to get through container to container if you don't have the right security profile. Kernel modification. So inside a kernel, you don't want a container mounting NFS and then making a file share somewhere else, because the container should never need NFS. But if you don't lock down your kernel modules, you'll be able to preload them into the container, which is really bad. And privilege escalation. So getting root access to the container. Once you've got root access to the container, you can start doing the things that are above it. So Docker's actually gone out and they've done a lot of work with the US government, but they have actually ratified their product with CIS. So if you're doing ISM for on cloud or not cloud, you have to have a hardening process for your underlying compute resource. Where I worked, we had CIS, and this made it really easy for the IRAP assessor to start looking at Docker because they've got it scored. They started doing this because they were talking with the NSA and still are in talks with the NSA in America, but we can leverage that here as well. So this has been fully ratified. You can go through, there's a lot of dry reading in this. I won't go through it all now, but it's there. You can fully harden the API. It talks about how to harden the API, some sane defaults, how to set up TLS encryption between the Docker daemon, and how to use either appapparmor or secomp properly in a production environment. So some sane defaults. Don't run the flag PID host or net host without knowing the risks. Because what you're actually doing is allowing the container to have root access to either the process running on the host or the host network. And that is not good if you don't know what you're going to be doing with it. So if you even have a look at the Kubernetes 1.2, it said that you needed to run nethost because it wanted to take over the networking stack. Google's now removed that, and it doesn't use nethost anymore because they wanted to try to get Kubernetes across more secure infrastructure and more secure places, like American banks, and they couldn't sign off with nethost because basically the container will have root access to the host network stack. And if you get into that, you can cause heaps of mischief. Don't bind your daemon to 0.0.0.0. I've seen this a lot in my doing consulting, that people we want to use a Docker remote API. We want to do deployments through it. That's okay. Lock it to the IP address and use TLS. And make sure that the TLS has got auth on it. Because at the moment, if you lock it down to TCP 0.0.0.0 and that port, anything can hit it with a JSON payload and it'll go, thank you. Okay, I'll do that. That's fine. So you don't want to do that. AUFS as a storage driver was the first storage driver that Docker used. There's a lot of issues with it. At the moment, you can get into underlying storage at the block level. Just don't use it. It's bad news. And use TLS. Whether it be, I know you shouldn't use self-signed if you're in a highly secure area. But if you're not, still use it like TLS everywhere, because otherwise Docker's sending a lot of information over plain text, whether it be to other hosts or itself. Even if you bind something to listen to the socket that Docker binds to, anything else can bind to that if you don't put TLS and auth on it. And it's a lot of information streaming on that socket. So you really want to lock that down with TLS. And as we spoke about before, just have one process running in the container. If it's an Nginx container, just have Nginx running. Don't have anything else. You don't need to. You're actually making your attack vector bigger. And if you look at things like how many have we had last year or this year, Heartbleed, Shell Shock, all of those things, it's not trivial to replace your containers if you're not prepared to do that. And it's not trivial to know what version of the packages are running in the container once they're running, unless you've got some sort of process that has an audit trail that you've printed out and you've forethought about that before the issue has arose. So one of the things that like we did with Claire was we just sent it to a Kinesis stream and we put it on S3. You could do that in OpenStack with any of the storage drivers and stream it. And then we had an audit trail of what versions were running then, and we had a database that could run, and we could grab the different versions that we needed to upgrade. We actually thought that was really reactive, so we built a better way. I'll talk about that a bit sooner. If you know what the process is running, that makes AppArmor really, really easy to use, because it'll be one folder, it'll be one process, and most of the time you won't need a lot of kernel modules. And there's no reason not to apply this. I mean, it's really, really simple. If we have a look at an example, you can have a look there. It just says that you can't delete. If you have a look, most of it will be denies. So there's no reason why a container needs to get into the syskernel security. Why would a container want to be starting to modify your underlying security sets on the kernel? Also, proc mem, container shouldn't be in there unless you know why. And if you know why, you could then add it to your AppArmor process. But as I said, I would source control these, and I would put clear comments in them of why you're allowing it, and I would go with don't allow unless it's absolutely necessary. And the good thing about this is you can fully test this in a development environment on your local machine. You can run AppArmor anywhere. And once you've got this and it's in source control, you can then share it with your developers, and they can start developing with the AppArmor profile locally. So now you've got security right at the very, very start of the development process. They're starting to look, and then it's not going to be like, oh, well, the container worked on my machine, but then you put AppArmor on it and it broke, so I didn't know that was going to happen. You allow the developers to have access to these profiles. They're not really like, I wouldn't consider them to have like highly secure information that you can't share them with developers. I mean, they're just denying network paths, they're denying kernel modules. But if you give them to the developers and they're able to develop with them running, you'll have a lot less issues when you start to get stuff out into the wild. My InfoSec manager from my last job sent me this. This was actually sitting on my screen when I come back from PuppetConf. And I think this is an absolute myth. Because everything that I spoke about till now come from the platform engineering team. InfoSec didn't build any of this, didn't take any of this through the architecture process. This was me and my team thought of all this. And that was because we wanted to use Docker, so therefore we had to take on board that we were going to cop flak, and we had to say, okay, what can we do to make InfoSec happy? If we want to bring a new technology in, how are we going, all their concerns are relevant, right? Their jobs, they're not, I know it sounds like most of the time they just want to make your life hard, but there's a good reason they want to make your life hard. And most of the people, especially in government, are really battle-hardened, and they know what they're talking about, and they're really experienced. So what you want to do is take the challenge on, meet them head on and go, okay, what do I need? What controls do I need to adhere to? What's the difference between what I'm doing in a container and what I'm doing on a compute resource? What more would you like to see from the solution so you will be happy with it? And start to work with them. Don't work against them. Just listen to what they have to say and really start to work with them. And it's going to be hard the first few iterations. There's going to be a lot of no's. There's going to be a lot of knockbacks, but just take it on the chin and keep working, because if you can get the solution down pat, you'll have one of the best solutions out there, I think. So as we spoke about before, this is basically what Claire looks like. and it actually talks to the CVE data sources from Red Hat, Ubuntu, and Alpine Linux. It updates itself every 3 hours, so you've got the latest CVE information. And what it does is, as a new image comes, it gets it, builds the file system, the layered file system in Docker, and scans it for any vulnerabilities. Now, this would be already that you've gone through your static code analysis and your application's okay. So this is like once the application's been built onto the container. So I've left out those things because I didn't want to get too much into like static and application ends and stuff. I just want to concentrate on Docker. So if once Claire runs and it scans it, so it can take, and it's not too long, it can take anywhere between 2 minutes and 10 minutes was the longest, depending on how many layers are in the actual Docker image. Once that runs and it's okay, it will push it to Notary, which we'll go to next. And what Notary will do is it will do two things. One, it will sign the image. Every layer of the file image will be signed with the crypto that we got from security, and it will be in the internal registry, so not on Docker Hub, but how we hosted it internally, so we didn't pull anything from upstream. Now, the second part of what Notary does is it protects the actual engine. So when the engine runs a command, say docker run, it will actually check back with Notary and go, is this signed? Is this crypto okay? Is the metadata of the container, the image okay? If any of those fail, it won't run the container. It has to have a clear communication with Notary, and they have to both concur that this is the same image that is in the registry. If anything like a man in the middle or anything like that that's interfered with it between the engine and the registry, it will not run. It will fail. And I think that's really powerful. So let's have a look at, this is what it looks like end to end when you're doing it from CD. So the Docker file would be checked into Git. It would then be pushed to Jenkins. Jenkins is the mastermind behind this. It's the orchestration framework, and it's also where the auditing point of view is, because Jenkins has got a really rich logging framework around it, and you can pipe all of that out into whatever logging framework you want, whether it be Splunk or Elk or anything else. So, but basically the Docker file comes in, it builds, then it runs the scan. As you see, if there's any critical highs, it fails the build. If you want to have that on mediums, that's configurable. That's all up to you. Once that Claire says to Jenkins it's okay, Notary will sign the image. Jenkins will then push the image to the internal registry, and the production compute resource will pull the image up. And as you can see there, if it doesn't concur with Notary that the metadata is the same and the crypto's not right, it will not run it. If someone gets onto your box and says Docker run from Docker Hub, it will not run. It will only run the images that are being signed off by yourself in your own registry, which is super good. Now, what you want to be, once you've got this up and running, what you can do, because there's going to be vulnerabilities coming out every day, you can actually start running this at night and run through all your images, and then in the morning either automatically patch them and then push them out if you've got the right quality gates of your application in place, or if not, what you can do is have a list in the morning of vulnerable things that you've got in the wild, and then you can have an engineer look after it and then do a manual push into production. But at least you're getting the latest scans every night, and you know that you've only got 24-hour period of what you've deployed and what's in actual production, and you should be. And this is where we found it to be really powerful, because within that 24 hours we knew all our images that were vulnerable, and we would have either remediation in place or it would be automatically remediated, which is really, really powerful. So I'm going to do a quick live demo. I've only got a couple of minutes, so hopefully I can get this done. So basically what I've got now running is just an Nginx container. And we're in temp. And that's one is LA. So you can see there that we've got a file that's owned by root. So what I'll do is just take control of that with... I'll cut it first. Sorry, I thought I'd have more time. So you can see that was created by foo. So decal foo file, okay, hacker. What was here? So basically, this is just going to use a dedical vulnerability, and it's just going to take control of the root file, and it's going to write to it, even though I'm logged in as a user leveling called hacker that has no root access. So this is just going to take a second. And then what we're going to do is get root access if I have time. I've got 3 minutes, so hopefully this will work. It's taking its time. What I might do is, while that's happening, I will, if you want the code, I've made a full test lab, so you can actually do this yourself. It's like fully automated. You just run figuring up and run like 4 commands. It's there, and you can play with it and see how appapparmor actually will protect. So what you'll find is that it'll actually run the C code, but it won't execute anything because appapparmor is not allowing the process to be able to have access to anything. It's still running. So I'll quickly go to questions while that's running. I've only got a minute or so left.
Question for Scott?
Scott, could you comment on how important it is to have 27,000 risk assessment skills at your level, where you're actually playing with the code? Because that's probably the language that the sys guys understand? Yeah,
I personally had it. I've had 27001 PCI and now ISM1 class, and I kind of led the sysadmin guys. My team didn't formally get trained in that, but I was in it. And plus, a lot of the guys were really good at like scripting stuff to hack stuff. So it was actually, we took security the other way. We went from like more of the attacker point of view. So one of the things that I've done that was really cool in Docker was I showed with the CD pipeline that you could do Nessus on EC2 instances, get the report out, spin up a Docker container with Metasploit and actually hit that exploit on the EC2 instance and then see if it was actually vulnerable or not. Security told me to pull that POC down after 2 days. They said, no, you can't do that. But it does work. So there's we were looking at it from the more attacker point of view than traditional InfoSec. But that was, but the guys, you're right, they didn't have that background. I had a security background, so that's why I was able to work through more of the policies and procedures, and they were able to do more of the tech work. But if we just have a look, I don't have much time. But as you can see, took control of that file. If we run just one more, this will only take a second. Cal root. And now I'm root. So I'll let you go and get the GitHub code, run the same tests with appapparmor, and that won't happen to you. So there you go. Thank you very much.